Okay, in this video we will talk about the converse, the contrapositive and the inverse. Okay, so these are the propositions we can create from the conditionals. Okay, so if you remember from my previous video, we talked about the conditionals, right? Now we will try to take an example. Now based on that example we will try to form the other propositions as well based on the conditionals. So let's recap what conditionals are. So suppose if we have a statement something like this one: if a quadrilateral is a rectangle, then it has two pairs of parallel sides. Okay, now conditionals we can define in like if P then Q, something like this one, right? So if I just write our P over here, so this should be our P, right? A quadrilateral is a rectangle, and this will be our Q, right? So it has two pairs of parallel sides. So generally we conditionals we write in something like this one, right? P and the right arrow and then Q over here, right? Now if I just draw that truth table over here, so we have seen this one before as well, right? In my previous video, when P is true and Q is true, this conditionals are true. Okay, but it will be only false when P is true but Q is not happening. That means if I just talk about it in a very simplistic term, if P is happening, Q has to happen. So that's the main intention behind a conditional, right? Now if P is not happening, Q may happen or may not happen, but in those cases also the conditionals will be true over there. Okay, now in this particular specific case where we have P equals to true, that means a quadrilateral can be a rectangle, right? So let's say we have a rectangle, then it definitely has a two pairs of parallel sides. That means Q is also true over here, right? So in that case our given statement is true over here, right? So we'll just mark it as a tick mark over here. So we have a statement, we have a proposition which is true we are dealing with, and it is a conditional. That means the parts of these statements P and Q, this P and Q is also a proposition over here, right? So both are true in this case. Okay, so that's why our given conditional is becoming true over here. Now based on this particular conditional we can form some new conditional statement as well. Okay, starting with this conditional P right arrow Q, P implies Q. Okay, so let us see what are those forms of conditional statements are. Okay, now the first one we talk about is the converse. Okay, now let's take this particular statement. Let's say I am telling the same statement something like this one: if a quadrilateral has two pairs of parallel sides, okay, then it is a rectangle. Now it has two parts. We can easily identify if something is happening, then something else is happening, right? So now if I just tally it out with my previous P and Q, then this part was my previous Q, right? The quadrilateral has two pairs of side in my previous statement, the main statement, right? And this part was P over here, right? So when we talk about a converse of a particular conditional, then Q is becoming the left hand portion of that implies statement. That means that arrow, right arrow, and P is becoming the right hand portion over here, right? So our new conditional is becoming something like Q implies P over here, right? So let us try to see whether this particular statement is true or false, given that we already established our P and Q is true, right? Both are true over here. Okay, so now if you remember from my previous video, we talked about when we have a conditional something like this one, then Q is sufficient condition for P, right? So the left hand proposition is the sufficient condition for P, and in that video we talked about very detail, like what do we mean by a sufficient condition and a necessary condition, right? So when we have a sufficient condition, that means when the Q is occurring, it guarantees that P is also occurring. Okay, so in that way, if let's try to see whether this particular statement is correct or not. Now we can have a lot of quadrilateral, something like square, or we can have rhombus as well, right? So both of these two quadrilaterals have two pairs of parallel sides, right? But they are definitely not a rectangle, right? This is a square and this is a rhombus over here, right? So in terms of truth table, so if I just try to maintain the same order, P and Q over here, we have previously seen this one, P implies Q, with this truth values over here, right? So if I just talk about this one, so currently we are facing this particular situation where my Q is true, right? Because a quadrilateral has two pairs of sides, even this for this square and this rhombus, right? So both having a two parallel pairs of sides, but the it is not a rectangle, right? So that's why if you see, whenever we talked about P implies Q, this was true, because when P is not happening, right, we do not bother about Q right over there, so it can be true and false. That's why P implies Q was true over here, but Q implies P will be false, because if I just see this one, Q is true, that means Q is happening, but P is false, that means P is not happening. But over here we establish that Q is a sufficient condition for P, right? That means the occurrence of Q guarantees that occurrence of P. If that is not happening, then this particular statement is false. That's why this one is becoming false over here, this particular statement. So given our statement is correct, our converse statement is false over here. Now from this truth table, we can easily identify when those two sentences will agree with each other. Okay, if you see it over here, when both P and Q are true, then they agree with each other, right? They all become true over here, right? Q implies P and P implies Q. Or when P and Q both are false, that time also they agree. In other cases, they do not agree over here. Okay, so that's the basic behind a converse. Now let's move on. Let's talk about inverse. Okay, now for that, let's analyze this particular statement over here. So if a quadrilateral is not a rectangle, then it does not have two pairs of parallel sides. Okay, now similar way we will try to identify our inner propositions here. A quadrilateral is not a rectangle and it does not have two pairs of parallel sides, right? Now if I just try to identify P and Q over here, this is actually P, but this is P bar because there is a not over here, right? We already talked about the negation proposition over in my previous videos as well, right? And this is becoming our Q bar as well, right? Because there is a not over here, it does not have two pairs of parallel sides, right? So looks like we got another propositions by changing this P to P bar and Q to Q bar. Okay, so you got another propositions, P bar implies Q bar over here. Okay, now let us try to analyze whether this particular statement is correct or not, given that our P and Q is correct. Previously we have seen that, right? We will try to take the similar example, square and a rhombus over here, right? Now these two are definitely not a rectangle, right? So for these two, P bar is correct over here, right? Now it does not have two pairs of parallel sides. Is it true? No, this is not definitely not true over here, right? Because square and rhombus both have two pairs of parallel sides, right? So looks like again this inverse statement is also false over here. So if I just see the truth table over here, so we have P, Q, P bar and Q bar. So we already seen what P implies Q is there. Now if I try to analyze P bar implies Q bar, right? So current statement was our P implies Q means both P and Q was true, right? So that's why P bar and Q bar will be false over here, right? So our P implies Q was true, but if you see it over here, in this particular scenario, our P bar is true, but our Q bar is false, right? So that's why our P bar implies Q bar is becoming false. Okay, so given the current scenario, this particular statement do not actually false. That means it is not having the same truth value for our P implies Q, right? So this is also false. Now from the truth table we already see, like when they will be agreeing over here, they'll be agreeing mainly over here on when both P and Q are false or P and Q are true over here. Same we have seen in our case of Converse, right? Now let's move on. Let's talk about contrapositive. Okay, now we will try to do it in similar way. We'll take a statement. The current statement is, if a quadrilateral does not have two pairs of parallel sides, then it is not a rectangle. So over here we have this one and this one, right? Now this is our Q bar, right? Because at slide number 1 we identified this one as our Q, right? And there is a not operator over here, so that's why this is becoming Q bar and this is becoming our P bar over here, right? So looks like we have another propositions over here. Q bar implies P bar over here, right? Now we will try to do in a similar way whether this is true or not. Okay, so for that what we'll do is we will try to just directly go to the truth table first. Okay, now if I just draw the truth table and see, if you see it over here, when P and Q both are true, our P implies Q bar was true, right? So that is fine. Now when these two are true, our P bar and Q bar is becoming false, right? So if I just go by the logic of the conditionals, when my P and Q both are true, right, in that time my P implies Q will be true, right? Now when my P and Q are true, my P bar and Q bar both are becoming false over here, right? So in that case Q bar implies P bar, right? So as Q bar is false, we do not care about the value of the P bar, truth value of the P bar, right? Because this conditional statement will be always be true. Okay, so looks like contrapositive is actually agreeing with, in terms of truth value, with our actual statement, actual conditionals over here. Now from the truth table also you can see it over here. So both of these columns having the same truth values over here. So from the given scenario and from the analysis of the current truth table, a contrapositive of a particular conditional statement is always agrees with the actual conditional statement. That means both are actually having a same meaning. If you just try to see it over here, if a quadrilateral does not have two pairs of parallel sides, okay, so in that case it cannot be a rectangle, because rectangle must be having a two pairs of parallel sides, right? So contrapositive and the actual statement always agrees with each other. That means they actually the same statement. So in mathematical logic we call it their equivalent statement. Okay, so we will see equivalent studies as well. So when we take two different conditional statement and try to find their truth values, if their truth tables are matching as is, then we say those two statements are actually equivalent statement. And when we basically try to prove that our particular proof is correct or not, right? So in those cases this type of logics will be helping us to determine, okay, this particular statement is actually same meaning as other statements over here. Okay, and also sometimes in mathematics when we analyze a particular statement, right, we also try to see whether their contrapositive version or their inverse or converse version is also true or not. Okay, now if I just put everything together, so this is our whole truth table of our main statement and their converse, contrapositives and the inverse, right? And if you see that this is our main statement truth values, right? So our contrapositive is actually agreeing with all the truth values of our main statement, right? And our inverse and the converse is actually agreeing with each other. Even if you see it from this truth table, this is also a interesting fact coming up. Our inverse of a particular statement and converse is actually agreeing with each other as well. That means a inverse and the converse of a particular statement is also equivalent over here. Okay, so hopefully this video was helpful. In future videos we'll try to see more fun stuff as well. Okay, see you in next video.